Much of what we do in biology, in biochemistry, is talk about building or breaking down big molecules. And since this is biology, a lot of these big molecules are polymers. And we already talked about that. Polymers are these long chain molecules where you have a repeating unit, the same thing joined together over and over and over and over again, like lots and lots of beads on a string. And while many different biological molecules look like that, they have this idea of beads on a string, and there's lots of different types. There's really just one chemical reaction that we use to build these long chains. So it doesn't matter what you're hooking together or what the end product's going to be, the reaction that you use to hook together the individual units is the same. So it's nice. It's a one-size-fits-all reaction. You only have to remember one thing for building. And this reaction we call condensation synthesis. So you can see the name right here, condensation synthesis. So here's a kind of diagram of what's going on in condensation synthesis. So first of all, we have a monomer here on the left. Mono means one, right? Mono, like mono, bi, tri, quad. Mono means one. So the monomer is the individual bead or the individual one unit that you're going to take like 100 of them and join them together to make a long chain. So the long chain is the polymer, means many of them all hooked together because poly means many. Monomer means one of the individual pieces that used to be separate but is now joined together. So on the left we have the monomer here, and on the right we have a monomer. So two separate molecules. Monomer number one, monomer number two, although they're the same thing, just duplicated over. Now, if we look on this side of this monomer, there is a hydroxyl group. You should know your functional groups by now. This OH is a hydroxyl. It's very commonly found as a functional group on molecules in biochemistry. And then if we look at this side of this monomer, there's just an H, a hydrogen atom. It's attached with a covalent bond, right? So there's a covalent bond there attaching this hydroxyl to the monomer on the left, and there's a covalent bond there attaching this hydrogen to this monomer on the right. All right, so if we get these two monomers and we put them side by side, so the one on the left and the one on the right, here's my hydroxyl, here's my hydrogen. When they get together, the OH from one and the H from the other can be combined, and you have two H's, two H's and an O. And there they are, two H's and an O. They combine together to make a separate molecule of H2O, which kind of is released, like given off, comes out, and then this monomer hooks itself directly to that monomer. So we get rid of this piece and this piece by putting them together and making water. And then we can hook the monomer on the left directly to the monomer on the right. And that is kind of what you see down here. Sort of a long loopy line like I drew. There's a straight line, just a covalent bond hooking these two monomers together. So once again, if we remember our chemistry, these are my reactants. This is what I'm starting with, two monomers. One has an OH and one has an H sticking off the side. And these are my product, or this is my product. So I've only got one product, this long chain. And we look at our arrows. It's telling me the reaction is going this way, right? We're starting with the stuff at the top and we're ending up with the stuff at the bottom. So there's actually two products in this reaction. Water is a product and this long chain is a product, which it's the beginning of a polymer. It's very short still, it's only got a couple joined together, but if we keep doing this over and over again, we can keep hooking more and more and more monomers together and end up with a longer and longer chain. Every time you hook these things together, you always have an OH on one and an H on the other, and water always comes out to create the join. And that's why it's called condensation synthesis. So synthesis means making something, building something, putting something together. So we're putting two monomers together. And condensation refers to the fact that water appears out of sort of nowhere. It's not out of nowhere because here's the two H's and the O's, but there wasn't any water up at the top, and now we have water appearing. Just like when you get condensation on the side of a cup or on a window pane, the water kind of appears. So this is condensation synthesis. You're building a big chain from individual separate pieces. Condensation synthesis.